So hello everyone. So thank you for coming. And today we're going to talk about mainframes. Now, usually when I talk to people about mainframes, when I mention the word mainframe, this is what people picture, like be it colleagues or fellow clients. This is what they picture. An old a picture, like a black and white picture of an old big iron box that runs in a God-forgotten data center, and that's running legacy applications that nobody cares about. You know, the company staff rather focuses on like sexier stuff like blockchain, Bitcoin, or other buzzwords. But this simply is not true. Like, this is what a real mainframe looks like one of the latest generation mainframe look like. So I'm not going to go through the specs in detail, like 141 processors, 10 terabytes. There are other specs that are more interesting, but I'm just like listing the basic specs just to make you realize that this is a freaking badass machine. Like, it costs millions of dollars. It has an uptime that is not counted in days, not counted in weeks. It's counted in years, sometimes decades. Okay? So this is not a machine that you buy, that you spend money on to run your email servers. This is a machine that you use to host your most critical business data, the kind of applications that you don't want to see go down, basically. Like, if a mainframe goes down, if an application in a mainframe goes down, the company loses money. The equation is as simple as that. And so, like, I just want to give you an example of companies that still rely on mainframe in 2017. So I kind of put a slide where I put all the logos of companies. So maybe there are companies that you know, maybe others that you do not know. But I want to, like, I'm paraphrasing my friend Chad here, who gave a talk at DEF CON last year about this subject. And basically what he said, like, I loved his statement that I'm just going to steal it right away. He said, every service, every critical service that you care about as a citizen, in a somewhat modern world and civilized world, every service that you care about is hosted on a mainframe somewhere. So be it your bank accounts, insurance accounts, retail, airliners, government, universities. Somewhere in there, there's a company that you care about that hosts a mainframe. And if it's not on this slide, it's on this slide. And I could have kept going because, you know, I just didn't want to have a whole presentation with logos. But believe me, that's like 90% of Fortune 100s still own a mainframe. And the second myth that I have usually is like, well, they're behind, you know, firewalls there. Don't worry about that. You can access them. That's just not true. It's like if you go to any branch office in a bank, you can see that they directly access the mainframe. You just find a way to plug in and you can tap it directly. Some mainframes aren't even on the internet. That's why you got something like this, for instance. So this is a website that's maintained by my friend Phil, mainframeproject.tumblr.com, and he just scans the internet looking for open mainframes and just put them on his website. So I think he has like around 500 mainframes. And this is just one example. You can find insurance companies, banks, etc. Some French clients. Anyway, so a little bit about me. My name is Ayoub. I'm a pen tester at Wavestone, which is a French consulting company. We have like a cyber security division. Sorry for the word cyber, but that's how it's called. So yeah, and I'm mainly a pen tester doing Windows and Unix stuff, right? And on an engagement in 2014, on an audit, we discovered, well, they told us about a VLAN that was hosting mainframe. And I was so freaking damn happy. It's like, it was like founded, like when you Google it and you see that it's a 50-year-old technology, you're kind of happy. It's like finding a Windows 3.1 on a network still running, and you're like, I'm still gonna exploit the shit out of this one. So I went online, I was looking for like CVEs, for vulnerabilities, for tools, and there was zero stuff. Like, and I mean it. Like up until now, like very recently, there's like 2 Metasploit scripts, but before that, there was like really zero. Like there was even one talk on DEF CON, like in 20 years of con, there was only one talk, which was done by Phil, that I encourage you to see, by the way. Anyway, so I decided I was like committed to really contribute to the community by writing tools, like doing the research, and hopefully giving talks about this stuff. So that's it. So I have my GitHub, like all the tools that I will show later, all the techniques. Basically, I like wrote a tool that automates all these techniques and all this stuff, so you don't have to worry about the technical details or anything. The idea is just to give you enough information to know how it works and to debug it a little bit. So if you want to follow me on Twitter, that would be awesome. So this talk, demystifying mainframes. So I think I made my case. Mainframes are important. We should care about them. Point. And so this talk we're going to talk about customer information control system, KICS, how it works, how we're going to play with it, hack it a little bit, and if we have time, we can talk about some post-exploit stuff, but that's not really the subject of the talk. But, you know, just to give you an idea. So let's get down to business. Basically, you're an engagement and you get this app that you need to pen test. Now, your client obviously have no idea how it works. So what can you tell from this app? Well, you can see that there are some green fields. So you might think that, well, we can inject some data. So maybe there's some form of SQL injection if there's like a database layer in the back end or something like that. And you would be right, that's something we could test for. But I wanted to go deeper. I wanted to understand how it really worked. And I think there's a talk about how to bypass control, like logic controls in the same way that you would play with HTML input, etc. There's the same way on this kind of apps. There was a talk that was given at DerbyCon a few years back by Dominic White, SenseBot, which was really awesome. He developed a tool like Burp, but he called it Birp. So yeah, but I wanted to go deeper to really understand how it works, because basically when you pen test a web application, you put yourself in the shoes of the developer and try to guess the assumptions that he made and try to test their validity. That's what you do, basically, to make the job easier. Well, I wanted to have the same insight with these kind of apps. I really wanted to know how they work. So this is what we know so far. First, it's not a web app. Second, the thing that you should know is that most communications with a mainframe, if it's mainframe is a machine on the network, it has IP address, etc. Most communication rely on something that's called TN3270 protocol. So don't get impressed by this name. It's just a fucking telnet. Okay, it was modified by IBM. They called it TN3270, but it's basically just modified telnet. It's still clear text by default. It doesn't use ASCII. It uses something older, it's called EBCDIC, but it's really, that's it. Wireshark understands it, and that's the main part. And like I said, we have absolutely no idea how it works. So to communicate with the mainframe, we're going to download the 3270 emulator. You can find one on Linux, or it's open source, x3270. So that's what we'll use. So anyway, now if you look on how to develop or how to put up interactive applications on the mainframe, you will get two main products that will pop up. IMS, we're not going to be interested in IMS because it's old. Nobody uses it anymore. And the second one is KICS, Customer Information Control System. Now, KICS, there are like, what, I'm going to say 100 books about KICS that were produced by IBM, designing security, hardening, user guideline, administrator guideline, specification, architecture, etc. But if you want to try to answer a simple question like, what the hell is KICS? There's no easy, simple definition. Like, it's mainframe jargon, like nobody understands it. What the hell is an MVS subsystem? So I'm going to try to give a simple definition that some mainframers may resent me for, but what the hell? KICS, to me, KICS is a combination of a Drupal and Apache Tomcat. That's it. Except that it was invented in '68. So think of it this way. Back in the day, there was no web, there was no internet. So if you want to develop an app and make it available to other machines, let's say a wire transfer app, well, you would have to go commando, like really write socket with assembly, do concurrence access, do your integrity checks, etc., and do it in assembly for every application. So, IBM came up with this middleware that basically it handles all this technical stuff for you, and you develop your app in COBOL, and you just host it on this sort of middleware. So that's it, basically. And now it's the version 5.4. So it kind of looks like this. So you have, I know not many people are familiar with COBOL, but bear with me, please. So you have your COBOL file, and like KICS, like, how do you say, on top of giving you this middleware place to host your apps, well, it gives you KICS, what it calls KICS APIs or KICS functions that you can use inside your COBOL code. That's why I compared it a little bit with Drupal. So you can use KICS functions instead of native code. So for instance, if you want to search for a file in COBOL to read it, well, instead of reading the file using native COBOL files, you can just use exec KICS read file. It's as easy as that. But the main advantage of KICS, the real main advantage of KICS, is that it can easily handle thousands and thousands of requests per second. Sorry. So if you want to play a game, for instance, let's try to order the following per number of requests per second. Like, how many Google search are there in the world per second? Can somebody shout out a number? Please. Big? Yeah, a lot. Yeah. Number, random? 10 million? A little less. Basically, there are 68,000 requests per second, Google search per second. A little bit more of YouTube views. There are 1.2 million KICS requests per second around the world. That would be your wire transfer. cash withdrawal, tax refunds, insurance, airlines, that's all through that small middleware. So it's a pretty big deal. So we're going to hack it, we're going to have some fun. So this is what it looks like, basically. We connect to the mainframe, we take the x3270 emulator, and we connect to the mainframe. We get this front screen that's called VTAM. It's just the welcoming screen. Let's keep it at that. So you have two apps that you can access. You can access TSO. TSO, it's time sharing option. It's just the bin bash on mainframe. You access it, and you can type commands like netstat, like ping, like stuff like that. It's just that. And then there's an app, there's a business app that's called Euro that we can access. And you can see that when you access it, you get user ID, password, very simple stuff. Authentication. When you authenticate, you go and you enter a customer number. When you enter a customer number, you get data. So that's what an application on a mainframe looks like. So what happened under the hood? Let's take a look. First, we were on VTAM. We accessed Euro, so we got transferred to a Kix instance. It's called a Kix region, but it's just a Kix instance. It's like when you go on a server in Apache, it forks. It's the same thing. So, and it launched what it called a transaction. A transaction on Kix is a program. Like sometimes it gets confusing. A transaction is a program, and every program is referenced by a 4-digit ID. In this case, the name of the program is the unspeakable CESN. It turns out, basically Kix takes this transaction ID, resolves it in an internal table, program control table, to retrieve the real name of the program, DFHSNP, love the names, which then resolves it in the program properties table, and it gets its location, loads it. Since it's an authentication program, it obviously talks with the security database. Now, there's no such thing as PAM. It's called RACF, right? So it's basically the same thing, does authentication, resource access control, etc. Not the subject of this talk. In any case, if everything checks out, if the password is okay, we move to the second program. So our program is actually composed of multiple sub-programs that are chained one after another. And the name of the actual business program is called Inc1. Now, again, Inc1 gets translated into a program and it gets loaded, etc. And then finally, we access that panel that showed us that we can access customer numbers. Now, once we are on the program, when we do a search, we enter a customer number, customer ID, and at some point, the application will read a file, so it will execute exec-kix read file. And what happened as you apply the file, the name of the file is actually pointing towards a location, so there's a lot of integrity control, check it to see if it was loaded by another application, etc. If it was not, it will fetch it from disk, do the search in COBOL, and if everything matches out, it gives us the detail of the number. So this is what happened basically during that brief interaction with the application. Okay, now that we know a little bit how it works and what it does, let's try to see what we can do. Basically, the first thing that we want to do, and one of the first things that we want to do on a web application, on a pen test, is try to find the admin panel, right? Like, why hack the app if we can directly access the admin panel and change the code, etc. So that's the same thing. We want to do the same thing. We want to follow the same philosophy. But there's no URL, right? So instead, we're going to play with keys and try to exit the app and see if we can go to other apps. Basically, this is just summarizing, basically. And so the idea is we click on PF3, we click on PF12, sometimes it's a reset button, sometimes it's PF3 plus clears. So there's a combination of tools that we can try to exit the app, and still be on Kix. I'm going to show you what it looks like because it's hard to explain it. So we are here on Euro, and you can see that just by clicking PF3, we cancel this authentication program, and we have a blank screen. And just for the anecdote, I promise you, I was stuck on this blank screen for hours because, like I said, there are like 100 books, and go fetch the information that tells you what this black screen is. So, and if you enter something, it tells you, hey, Kix transaction is not recognized. So it basically is asking you to enter the name of a program to go to. And this is what you start thinking, hey, am I really obliged to go through the authentication program to access the business app? What if I type Inc1 there? Do I really jump directly to the so that's the kind of interesting stuff that we can find. And since every program is only 4-digit long, why can't we brute brute force it. And so there are tools that do this actually. There's a Python script on SensePost GitHub. There's an Nmap script that was developed by Phil Young. And I put in a third program that basically like does it and also takes a screenshot of the transaction to tell you like which programs are installed so you can see what they look like. But let's go further. There are some default programs that are shipped with every Kix install. Now, these are default and they're shipped by IBM. So we saw the first one, CSN. Let's see the next one that's a little bit more interesting. That's called CMT, for Master Terminal Console. Now, you know it's going to be something good. So when you type CMT, it gives you a menu with like 4 options. What it does actually, it lets you, CMT lets you control every resource defined on Kix. By resource, I mean every file that is installed, every program, every data, DB2 connection, database connection, web service, Java, etc. So it lets you control all these parameters. So for instance, if we go to the Inquire menu, you can, for instance, list the files, but you can also list the transactions. You can see the ones that I highlighted. You can also do a lot of stuff. Now, all of this will be incorporated automatically in my tool, so you do not have to navigate through the menus, etc. It will do it, give it to you automatically. I will show you later. So if you want to list the transaction, you don't have to brute force them actually. You just go CMT inquire transaction, and you list all the transactions. So you can see from the blank screen, we go to CMT, type inquire transaction, and we'll list all the transactions. And remember, everything in green you can edit. So here it's enabled. If you want to disable it, you just replace it by disabled. Press enter, and you just shut down an application that processes 300,000 euros per day. You can also get information about the system. So we know that we're running a Kix 3.2 default user because, hey, remember, we skipped authentication, so we had an anonymous user. So it's called the Kix user, and we have a ZOS 3.10. 1.10, sorry. So that's just basic information. Again, if you want to play with the variables and change the max task to make it fall down, you can do that. And you can also list users, scrap user IDs. So you can run the CMT inquire about task, and you can see other users. So you can try to perform a horizontal brute force, for instance, on via TSO. You can also list files. That's what we're interested in, because what if we can access the file that is hosting all the customer records? That would be very interesting. Now, files on Kix have a special type. They're called, prepare yourself, VSAM KSDS files. Now, that's a fancy name to say that it's a file with 2 columns, 1 column that has an index, and for each index there's a value. It's simply like a file, it's table file with 2 columns. That's it. There's an index that you should be aware of, and there's a record value. That's it. And every file has options. So in this instance, Eurocli is closed, disabled, but readable. So in order to read it, it needs to be open, enabled, and readable. So you need to mess with this option a little bit before reading it. So and to get information about the key index, you can just click on it, and that's it. So to sum up, but the thing is, through CMT you cannot actually read the file. You can get configuration files, you can remove the file, you can do a lot of stuff, but you cannot read the file. You can even shut down the whole Kix, but you cannot read the file, and that's too bad. So that's what we'll try to do later on. So this is a list of stuff that you can do with CMT. That's fine. So to actually execute stuff, we need to go through another program that's called CSI. Now, CSI is also available by default, and it just executes the Kix APIs, the Kix functions through the terminal. So you remember the COBOL code that we saw? So instead of writing a whole COBOL application, compiling it to test this stuff, you can just straightly run these functions through the terminal. So it looks a little bit like this. You type CSI from that blank screen, and you can see that you can access a lot of functions. And the one we're going to be interested in for now, it's read file. So for instance, it looks a little bit like this. So read file, Eurocli, the index that we want to read, 0, greater than equal, because we don't know if it exists. And you can see that we read like a few bytes of the record. Like to read completely the byte, we need to store the content in a variable and read it. Okay, pretty interesting. You can type F5 and you can access the whole content of the variable, and you can see that we read the whole record. So to sum up, in order to read a file using CMT and CSI, you need to first find the right combination of keys to exit the app, access CMT, list files, make them readable, open, and enabled, then go through CSI and loop through all the keys in index as possible. So that's kind of pain in the ass. So that's why, like, basically I wrote a tool that will automate all of this, and you can see that well, it's called Kickspawn. It's on my GitHub, and you can just get file uRCLI, and it will find the right combination of keys, and it will change the proper attributes of the file, and it will just list the contents of the file. Now, what's interesting about this is that basically, you know, when sometimes you're in a web pen testing, and you find like a path traversal or something like that that lets you read any file on the system, and you get, you know, password database, and you go to your client and you're like, hey, I got your password database, and he's like, fuck off, it's behind firewall, you can't access it anyway, and you're so mad, etc. But because he doesn't want to fix it. But you don't have that problem on a mainframe because there's no other node on a mainframe. That's it. That's the end of the channel. If you get read access on a mainframe, you get access, you know, balance accounts. You can access customer data. That's it. It's game over for the company. You don't care about a shell if you can change your balance account. I mean, you know. So, but since we're between hackers, let's see if we can execute code on this stuff. Let's see if we can have a shell on this stuff. So there's this thing that's called, there's this function on CSI that's called spool function. Now, what a spool is basically just a file. It's the dump of a file. It's the, like, when you run a program, it dumps its like debug information into a file, and that file is called a spool. That's it. And CSI, like, kicks give you the ability to create a report, write data to it, and send it to other users to report stuff. Now, some users are more special than others. Especially, there's like on a mainframe, there's something that's called the job entry scheduler. Now, this used to be a physical slot on a mainframe where you put punch cards and you push them and they get executed. Now, obviously, since it evolved, now this entry scheduler is basically a virtual subsystem, and every file that you send to it gets executed, no questions asked. And so that's what we're going to do, basically. So the theory is we create a spool using kicks. We get a file descriptor. We write the code line by line. It's a bit painful. And then we close it and send it to the internal reader, the JS spool. So that's what it looks like, basically. So using CSI, spool open, output, user ID, this is the most important part, user ID in TRDR. This is the handle for the internal reader. And we get a token, and then we go to the F5 panel variable. We click on F5, and then we write. Now, this is GCL, this GCL code, and I know a lot of people, or some people in the room hate it, but it's just focused on the FTP, right? It just does FTP. That's what you need to know. That's it. It's not as impressive as it looks like. It's very easy to learn. Don't worry. It's like the same structure all the time. So, but it just executes FTP. That's what we care about. And then we write line by line this code that we just wrote, and hope and hope and hope to have an FTP connection. So basically, and you know, yes, it works. So that was one of the happiest days of my life. Basically, I was just struggling with this for weeks. But you know, it fucking sucks because it's just an FTP connection. Let's try to automate this stuff. So I got it to the next level, and I wrote a GCL script that basically creates a file, writes code into it, and then executes it. That's it. Because, you know, in GCL, you can't do sockets, etc. So I wrote it using a script that's called Rex. It's like Python on mainframe. That's it. It's as easy as that. You can learn it in an afternoon, actually. But it's just, you know, I try to make it as short as possible, but still nice and readable, so you can edit it if you want. Now, obviously, this will all be automated, so you will not even look into this when you actually download Kickspawn. So it looks a little bit like this. We start our listener, and then we launch Kickspawn. We mention the application, Euro, and we choose reverse TSO. And so it will find the right combination of keys. Again, it launches CSI, and it pushes the stuff, and we get executed on the mainframe. And that's that, and you can execute command, etc. Now, the thing is, the interesting parts about this stuff is that, first of all, I don't expect everyone to know GCL, rec, etc. So I embedded a lot of payloads in it. So you have reverse TSO, bind TSO. If you're not comfortable with TSO and you prefer rather Unix commands, you can also choose that payload because there's a Unix in every mainframe ZOS. So That, if you're not familiar with ZOS, you can just switch to the Unix environment, POSIX compliant Unix, so you can find your way. So you have a reverse Unix, bind Unix. You can FTP commands if you want to download a file like the database, RACF database, crack some passwords. If you don't want to leave your payload on the mainframe, you can just put a stager and then send the script. It will execute it in memory, so you don't leave your real payload behind. So and if you're savvy enough, you can just write your own GCL. So all of these payloads are incorporated into Kickspound, and you can just choose them. The second interesting part is that when we executed this code, take a look at the user ID that the mainframe gave us. Remember, we skipped authentication, so we're not supposed to, and we're supposed to have the anonymous user kicks user, but actually it gave us the user start2. Now, who the hell is this user? Well, when you look at it, start2 is the user powering other important stuff like security database. It's the user running VTAM, the interface, the greeting interface. It's running some other interesting subsystems or programs on ZOS, on the mainframe. So actually, this user is kind of important. And so maybe it has a lot of privileges, and most of the time it does. So, we can pretty much exploit it and have fun with it. And the interesting point number 3 is that, remember when we created this dump file that we sent to the internal subsystem, we chose to execute it not locals. It means we executed it on this mainframe. What if we put Washington, DC? What if we put remote system? We could have executed on another mainframe that had a trust relationship with the mainframe that was vulnerable. And that way, execute on another mainframe via, what is it called, network job entry. There was a talk at DEF CON about it last year by Phil in chat, and I encourage you to have a look at it. They talk about network job entry. But basically, you could just execute code on another mainframe. It's like, Unix machine trusting each other. It's the same principle. Now, there are some problems. Sometimes the spool option is turned off, so we cannot create this file and push it to the internal reader to get executed. But the most common thing that I encounter is that CSI is not available. You get shut down right away. You cannot even read files. So we're going to see how we're going to deal with them. So spool equals no in the configuration file of Kix means that, hey, you cannot create a file. Well, it doesn't matter. We have something else that's called transient data queue. Again, IBM with the names. Transient data queues are just temporary files. That's it. Temporary files that are used by application on Kix to hold temporary data. Just going to make it as simple as that. And sometimes admin do this. They define a file, and they link it to the internal reader. And so if you can find this, you can, well, even if spool is closed, you can still execute code using this file. Now, I'm not going to go into detail on how, etc. It's basically because it's handled automatically on Kickspound. You just -I, and it will check for both options, and it will give you information about how to use it. So you don't have to worry about it. So I'm just going to skip it. One down. But basically, just to give you statistics, 30% of the mainframe that I tested had either spool equals yes or TDQ that were available. So 30% of the cases you can get actually to execute code. On CSI though, CSI not available, that's a bigger problem because if you can't access CSI, that's bad. So sometimes you get this transaction is not allowed. And the rule that is usually in place to protect it looks a little bit like this. Now it says, it's just a RACF syntax, but basically it says, don't let people access CSI, universal access equals none. Now what we did here, the protection was placed on the transaction name. Now the transaction name is just a link to a program. So if we can modify somehow this transaction name and replace it by something we can have access to, we win. That's basically what it looks like. We access another program that's called CEDA, and this one is the most dangerous one. It lets you alter everything on Kix. And yet, it's less protected than CSI. Because CSI, people see that you can execute stuff, so they kind of forbid it. But CEDA, they're like, oh, well, who knows how to use it? We're just going to let it. And so a lot of places I see CSI that is forbidden, but CEDA, well, you can access it, and you can just alter resources. So for instance, CSI, we're just going to rename it CSPS or CSPK or something like that, something that we have access to, and we can bypass this restriction. So we just use -- bypass on Kickspound to do it. So we start our listener again, and we use Kickspound, and you can see that we don't have access to CSI. But if we add the bypass switch, you can see that first it will copy CSI and CMT to other transactions, to other names, CSPK, and now it works. And you can see that we have a shell. This time I chose a Unix shell just to show you that actually it's just a regular old Unix. So now we execute a code on the mainframe. Maybe we have privileges, maybe we don't. Can we elevate it? Can we get more privileges? Now, what you should know about z/OS, which is the operating system that is running on a mainframe, there are three main privileges. There's the special privilege. It's the equivalent of root. Like if you have special, you can alter, do whatever the hell you want. There's the operations privilege. If you have operations, you can access any file. You ignore all rules. You can access any file, and you can thus become special if you want. Then you have the audit privilege, which lets you manage login classes, etc. Now, this is like, there's so much to say about this, but I'm not going to go into detail. But basically, all your privileges are held in a structure in memory that is local to your virtual address space. So basically, every user, every task has its own virtual address space. And there's a structure in there in the private memory section that basically holds your privilege. There's a simple bit that says this user is special or he is not. That's it. And it's like special offset, etc. So the idea is, what if we can change this? Now the problem is there are a lot of protections, memory protections on z/OS. There's supervisor problem state. There's like the security attribute that is attached to every memory page. So you know there are like 16 rings, equivalent of rings. On Intel you have 4 rings, 0 to 3. On z/OS you have 16, 0 to 15. So it's a bit more complicated. But the idea is, what if we can change it? But to change it, we need to go into kernel mode. Or supervisor state, if you will. Now, the way that happens on Linux, if you want to go to kernel mode, you just load a kernel with insmod or modprobe, and that's it. So if you want to protect this function to go into kernel mode, you just focus on these 2 entry points, just simplifying. But on z/OS, it's a bit different. It doesn't work that way. Actually, there are multiple directories that are considered kernel directories, and if you put a program in it, automatically it can go into kernel mode. I'm going to let that sink in a little bit. So it's like there are libraries. If you put a program in it, they get kernel mode protected. And you can have 100 libraries on the mainframe that have this special authority. So it's called, they are called authorized program facility, APF libraries. So if you mess up on one, you mess up the system. It's scary. So the idea is, we run a program, we list these APF libraries by looking into memory, into common region. We can find them, list them, see the privileges that are associated with each one of them, find one where that we can alter. We compile a program, we put it inside, and that program will launch, go into kernel mode, look for that special bit in memory, turn it on, and it'll give us special. That's the idea. Now, it takes more than one slide to explain it, but basically that's what it does. The only problem, the only challenge actually is that it needs to be written in assembly. If you want to go into kernel mode, you need to go in assembly. That was a bit pain in the ass to learn Z architecture assembly. But other than that, it's fine. So I'm just going to show you a tool that I did that does it, so you don't have to go through the trouble again. So it's just like a tool that's open source. Again, it's available on my GitHub. So you can see here that in assembly we launch the mod set instruction. We go to key 0, we switch keys to have the same key as the memory page that holds the security attribute. We go to kernel mode, mod supervisor state, and then we find that memory structure, we flip the bit, and the program becomes special. The virtual address space that is associated with the program, becomes special. But our user is not special because he's in another virtual space. So we need to add the alter user ID special operation. So we need the program to give us special. Basically, that's what it does. And as you can see here, we list user 0. He has 0 attributes, right? And then we execute this script, elf.apf, and we list all the APF libraries. We scan memory looking for them. We look for the RACF profile, the security profile associated with each library. We choose one, and you can see that afterwards it compiles, launches the program, and afterwards we have special operations, so we're root on the system. So that's how it works. So thank you very much. I want to thank these people that I work with on research, etc. We exchange stuff, IBM, obviously. And so thank you. And if you have any questions, please go ahead.